Hi, I am Oliwia Sobotnicka, student of the University of Gdańsk in the field of production of audiovisual forms for the second year. We will talk about special effect on the example of the Move avatar from 2009. About 60% of the film is CGI effect. The enter and TV moments. This film has won huge admiration around the world. The work used technologies called motion capture. Now, today from other films, the technique has the ability to capture characters' emotion and muscular movements. The actor played in special costumes with dudes that we translated by a computer program into the behavior of the moving characters.
Fixing. Tuluk fixing. Wait, min. Tuluk. Stomny at efekty. Hey, my big blue ass, brother. Yeah.
Another effect is the soul called street wheel. It's a controller with an LCD screen without a classic camera. It reserved real-time traffic data. It's acted a window into the digital world in lifetime, so you could make adjustments on the fly.
So, hey folks, my name is Matt, and I was the performance capture supervisor on Avatar. So this is what you may have heard as the volume, the performance capture stage. So we're going to show you how we create motion on the stage, how we go live, how we integrate in all the different virtual elements, how we lay down shots. So just kind of take you through the basics of the performance capture process. So, you guys familiar with performance capture? You've seen the process that you're making of. It's getting pretty well known these days, but I'll just go over the basic premise. Our first objective is to figure out what the actors are doing in the volume. And what I mean by that is have the ability to recreate their motion in 3D space in a machine, in a computer. And that goes down to the skeleton movement, because that's really what we're after, is how their joints are moving, how the bones are oriented every frame. So the way we do that is first we register the locations of these markers on their suit. And we also figure out how they move. Even though these suits are fairly tight, they can also move because our muscles slide on the surface of the bone, so it's not an exact replica of what the body's doing, it's an approximation. So our software is designed to figure out from that approximate surface movement what's happening underneath, what the joints are ultimately doing. So part of that process is building an exact replica, or as close as we can, of each performer's skeleton, and also their range of motion. So we've defined how they're built and how they move at the ground level. And once we have that, then we can then associate their movement and their body type with the character that they're playing, which is also a unique relationship because everyone's built differently, everyone moves differently, and then the character that they're playing, they have a unique relationship based on how that character's built and how they should control it. So for every character that we played, we have a unique file that describes that association. So when you see a live performance, it's first calculating their motion, applying that to this other filter, this other file, and then taking that motion and putting it on the Navi or the avatar. So it's kind of like this translator. It says, okay, when he does this, the Navi or the avatar should do this. And it's usually very, very similar, but since they're not built exactly the same, then we have to describe that relationship in extreme detail. So the way we calculate the surface information is through these cameras. We've got about 40 or so distributed throughout this grid, and so it's an optical system you're probably familiar with. So we have to see the markers, at least most of them, from two cameras. We can sometimes use a single camera too, but we'd like to see them from at least two cameras most of the time. the whole MO here is wherever Jim wants to put performers, we should be able to recreate it. If it's in the volume, then it's fair game. So it doesn't matter if there's set pieces, other crew, cameras, grips, himself, other performers. We have to be able to recreate their performance in real time.
Everything in the move is computer generated. There are so practical effects. Explosion, water, etc. is numbers, and none of the things real happened. Digital designer Steve Messing traveled to China, where he documented panoramic photo and the detailed location that we used as models for the generated landscape of Pandora's world. The device that could allow the 3D machine was a computing engineer called Pan Rai. It allowed, among other things, to calculate the illumination of objects. This solution allowed to observe how the forests grow in real time, how a tree grows when the sun's rays fall on it. This is what makes the move look so good.
Filmed without CGI may surprise you. Zoe Saldana was required to work with a gray plastic contraption to model as the leaf, while holding a water bottle covered in duct tape to simulate water coming from the tape. We guess that's why they call it movie magic.
It's the most high-tech film in terms of its execution.